We discussed the chapter real numbers of class 10, and there is one optional exercise for extensive learning. We are doing these problems in today's session. Let us start our class. Class 10 class 10 real numbers. Real numbers. So we are doing optional exercise. Optional exercise for extensive learning. For extensive learning. Let us do our problems. This is the second problem. Is 7 multiplied by 5 multiplied by 3 multiplied by 2 plus 3 a composite number? A composite number. Justify your answer. Justify your answer. Justify your answer. So we can write the number, given number. 7 multiplied by 5 multiplied by 3 multiplied by 2 plus 3. This is equal to, in both this 3 is the common factor. So this can be written as 7 multiplied by 5 multiplied by 3 multiplied by 2 plus 3 multiplied by 1. This is equal to, we can write 3 multiplied by 7 multiplied by 5 multiplied by 2 plus 1 plus 1. So here we get 70, here we get 1. This is 3 multiplied by 70 plus 1. This is equal to 3 multiplied by 71. So finally we get 213. 213. So here the given number can be written as the product of two prime numbers 3 and 71. We write it, the given number can be expressed as the product of as the product of two prime numbers. Two prime numbers. Hence, the given number is a composite number. The given number is a composite number. So let us discuss this problem. Here, this is the given number. So this is the first term in this step. The second term is multiplied as is written as 3 multiplied by 1. The second term is written as 3 multiplied by 1. So we can write 3 multiplied by 7 multiplied by 5 multiplied by 2 plus 1. So this is how we can get 3 multiplied by 70 plus 1, which is equal to 3 multiplied by 71. Hence, the given number is expressed as the product of two prime numbers, and it is equal to 213. Since the given number can be expressed as the product of two prime numbers, it is a composite number. That is, here 213 equal to 1 into 213 and 3 into 71. Next, we consider the next problem. Third problem. Students can refer the page number 23. This is page 23. Prove that 2 root 3 plus root 5 is an irrational number. Is an irrational number. Also check whether two square root of 3 plus square root of 5 multiplied by 2 square root of 3 minus square root of 5 is rational or irrational. Is rational or irrational. So we have to prove that the number 2 square root of 3 plus square root of 5 is an irrational number. To prove this, we follow the contradiction method. To prove that, to prove that 2 plus 2 square root of 3 plus square root of 5 is an irrational number, is an irrational number, we follow contradiction method. In contradiction method, we assume that the given statement is not true. That is, we assume that the given statement is wrong. So we assume that we assume that 2 square root of 3 plus square root of 5 is a rational number, is a rational number such that such that 2 square root of 3 plus square root of 5 can be expressed as a by b, where where a, number one, first condition, a and b are integers. A and b are integers. B is not equal to 0. This is the first condition. And the second condition, highest common factor of a and b is equal to 1. That is, a and b are coprimes. We assume that a and b are coprimes. So a and b are coprimes. What is the definition of coprimes? If the highest common factor of a and b is 1, then we say that the two numbers are coprimes. So here we assumed that the given number is a rational number such that it satisfies two conditions. This is condition 1 and this is condition 2. Now we develop a mathematical argument to prove the result. So this is equal to this can be written as we rearrange the given problem as 2 square root of 3 equal to a by b minus square root of 5. We have rearranged the given problem. So rearranging the given problem, we get this. Squaring on both sides. Squaring on both sides. Squaring on both sides. Here we get 2 square root of 3 whole square equal to a by b minus square root of 5 whole square. So on the left hand side we can write 2 square root of 3 whole square equal to 2 square multiplied by square root of 3 whole square. This is equal to 4 multiplied by square root of 3 whole square. Square root of 3 whole square is 3. So we get this is equal to 12. On the left hand side we can write 12. So using the formula a minus b whole square, using a minus b whole square equal to a square minus 2ab plus b square formula, we can write to the right hand side as this is equal to, the right hand side can be expressed, can be expanded using the formula a minus b whole square equal to a square minus 2ab plus b square. We use this formula. So a by b whole square minus 2 multiplied by a by b multiplied by square root of 5 plus square root of 5 whole square. So this is by using the formula a minus b whole square on the right hand side term. Now in place of the left hand side term we can write 12. So this is equal to 12. Therefore this is equal to a by b whole a by b whole square. It can be written as a square by b square minus 2 square root of 5 a by b plus square root of 5 whole square. Square root of 5 whole square is its value is 5. Square root of 5 whole square, its value is 5. This is 12 equal to a square by b square minus 2 square root of 5 a by b plus 5. This is what we have got using the formula a minus b whole square equal to a square minus 2ab plus b square. Now we bring this term to the left hand side and 12 to the right hand side, so that we get 2 square root of 5 a by b equal to a square by b square plus 5 minus 12. So this can be written as a square minus 7 a square by b square minus 7. So this can be further simplified as a square minus 7b square by b square. So 2 square root of 5 2a by b square root of 5 is equal to a square minus 7b square by b square. Now from this we can write square root of 5 equal to a square minus 7b square by b square multiplied by 1 by 2 multiplied by b by a. Why? Because we have to take reciprocal of 2a by b. 2 multiplied by a by b on the left hand side. So when we transpose it to the right hand side, we have to take the reciprocals of those values. So this is equal to a square minus 7b square by, in the denominator we get 2ab square root of 5. Now we continue our mathematical argument to prove that the right hand side term is a rational number, and we have already proved that square root of 5 is an irrational number. Hence we get a contradiction. Since we get a contradiction to the fact that square root of 5 is an irrational, our assumption is wrong. So let us start our mathematical argumentation to prove that the right hand side term is a rational number. Here a is an integer and b is an integer. This implies a square is an integer and also b square is an integer. From this we can write a square minus 7b square is also an integer. This is why, because a square is an integer, a square is an integer and 7b square is also an integer. This is why, because b square is an integer, 7 is an integer, and 7b square is also an integer. So this is our mathematical argument. That is, the product of two integers is again an integer. The product of two integers is again an integer. This is the property we have used. This implies a square minus 7b square is an integer. This is why, because the difference of two integers is again integer. So we can write here product of two integers is product of two integers is an integer. So this is the reason we have written a square. So a square is a square equal to a into a multiplied by a. So we apply this. The same reason this is also 7b square. 7b square is also an integer. Same rule is applicable. Product of two integers is an integer. The product of two integers is again an integer. This is the closure property of integers with respect to multiplication. And now here we can write it a square is an integer, 7b square is an integer. The difference of two integers is again an integer. So we should write this difference of difference of two integers is again an integer. So this is the closure property with respect to multiplication. So these steps are written. So the numerator part here in this problem, a square minus 7b square, the numerator of the right hand side is an integer. We have proved this. Now we consider the denominator 2ab. We have to prove that 2ab is an integer and 2ab is not equal to 0. So 2 is an integer, a is an integer, and b is an integer. And also 2 is not equal to 0. Highest common factor of a and b equal to 1. This from these concepts we can decide that 2ab is an integer. 2ab is an integer, and since 2 is not equal to 0 and highest common factor of a and b equal to 1, the highest common factor of two numbers is equal to 1 only when a and b are not equal to 0. So both a and b are not equal to 0. So here from this definition what we can get is and a is not equal to 0, b is not equal to 0. From this we can write that 2ab is an integer and 2ab is not equal to 0. So the numerator term is considered here, 2ab is considered, and it is proved that 2ab is an integer and it is not equal to 0. So now we use the definition of a rational number. What is the definition of a rational number? If we can write, if you can write a number p by q such that p and q are integers and q is not equal to 0. This is the definition of rational number. Now, using this definition, so this implies p by q is rational. P by q is a rational number. So using this formula, we can write a square minus 7b square is an integer, 2ab is an integer, and 2ab is not equal to 0. So this implies that a square minus 7b square by 2ab is a rational number. Is a rational number. We can write it is a rational number. This is by the definition of rational number. Let us see the above definition. P, if a number is written in the form of P by Q, where P and Q are integers and Q is not equal to 0, then P by Q is a rational number. This is the definition of a rational number. Now compare a square minus b square. It is P. This is P, and 2ab, this is a Q. So a and b, P and Q are integers, and Q is not equal to 0. That implies P by Q is a rational number. So comparing this with P and Q, we get that a square minus 7b square upon 2ab is a rational number. So if this is a rational number, this implies that if a square minus 7b square by 2ab is a rational number, then we get that square root of 5 is a rational number. So this implies that square root of 5 is a rational number. So this is not true. We know that, but we know that square root of 5 is an irrational number. So we got a contradiction. What is the contradiction? We got a contradiction that square root of 5 is a rational number. Square root of 5 is in fact a irrational number. So we write that step. We got a contradiction. We got a contradiction to the fact that square root of 5 is an irrational number. So we got a contradiction statement to this fact. Why this contradiction has arisen? This is because the contradiction has arisen because of our wrong assumption. So therefore our assumption that 2 square root of 3 plus square root of 5 is a rational number is wrong. If this is not a rational number, then it is an irrational number. So we note down the definition of irrational number. A real number which is not a rational number, is called an irrational number. Therefore, therefore 2 square root of 3 plus square root of 5 is an irrational number. We proved this result by contradiction method. We can write it. We proved this result by contradiction method. We proved this. We proved the result. We proved this result by contradiction method. Now, in the given problem, they have asked whether now consider 2 square root of 3 plus 5 multiplied by 2 square root of 3 minus square root of 5. So this is equal to 2 square root of 3 whole square minus square root of 5 whole square. This is using the formula. We use the formula a plus b multiplied by a minus b equal to a square minus b square. So using this formula, we can write this step. This is in the form of a plus b multiplied by a minus b. Hence, we can write it in the form of a square minus b square. Now, what is the value of 2 square root 3 whole square? 2 square root 3 whole square equal to 2 square root 3 multiplied by 2 square root 3. This is equal to 2 multiplied by 2 is 4 and root 3 multiplied by root 3 it is 3. This is equal to 12. So we can write here 12 minus here what is the value of square root of 5 whole square? Square root of 5 whole square equal to 5. So we can write here 5. Finally we got this is equal to 7. So 2 square root of 3 plus square root of 5 multiplied by 2 square root of 3 minus square root of 5 equal to 7, and it is a rational number. Therefore, because 7 can be written as 7 by 1, we can write this. 7 is a rational number since 7 is a rational number. Rational number, we get that 2 square root of 3 plus square root of 5 multiplied by 2 square root of 3 minus square root of 5 is a rational number. This is how we prove this result. Now let us see this briefly. prove that 2 square root of 3 plus square root of 5 is an irrational number. To prove this result, we follow contradiction method. In contradiction method, we assume that the given statement is not true. So we assume that the given number is an irrational number. We assume that the given number is a rational number. We have to prove that the given number is an irrational number, but we assume that the given number is a rational number. This is a contradiction method. So, if we can write the given number as a rational number, then we can express it in the form of a by b, where a and b satisfy two conditions. A and b are integers, b is not equal to 0, highest common factor of a and b equal to 1. Now, we rearrange the given problem. 2 square root of 3 equal to a by b minus square root of 5. Using the formula a minus b whole square on both sides, we square on the both sides. We square on the both sides, on squaring on both sides, we get after simplification, we get that square root of 5 equal to a square minus 7b square by 2ab. This is how we got it. Now, we consider the right hand side terms, that is the numerator and denominator. These are proved to be rational, the integers. We have proved that a square minus 7b square is an integer, and after that we prove that 2ab is an integer, that is the denominator is an integer, and the denominator part is not equal to 0. So when we prove this, this is of the form of p by q, where p and q are integers and q is not equal to 0. Hence, p by q is a rational number. Using the definition of this rational number, we can say that a square by minus 7b square by 2ab is a rational number. If this is a rational number, then the left hand side number square root of 5 must be a rational number. This is what we have got. But we know that the square root of 5 is an irrational number. We have already proved this result in the previous classes. Square root of 5 is an irrational number. This is true. But we got in this case that square root of 5 is a rational number. This is a contradiction to the fact that square root of 5 is a rational number. Hence, our assumption that 2 square root of 3 plus square root of 5 is a rational number is wrong. If this assumption is wrong, then it is not a rational number. If this is not a rational number, then we apply the definition of a real number. A real number which is not a rational number is called irrational number. So using this definition of irrational number, we can conclude that the given number 2 square root of 3 plus square root of 5 is an irrational number. So we proved this result by contradiction method. After proving this result, we consider this product. It is given 2 square root of 3 plus square root of 5 multiplied by 2 square root of 3 minus square root of 5. We compare this with a plus b multiplied by a minus b. So it can be written as a square minus b square. Using this formula, we can write this result, the product as a square minus b square form, in the form of a square minus b square. So after simplifying this, we get 7. 7 is a rational number because 7 can be written as 7 by 1. So it is a rational number. Since 7 is a rational number, the left hand side product is also a rational number. Hence, the given number is a rational number. This is our justification. Now, let us consider the next problem. Dear students, in this topic, there are only two problems, and after completion of these two problems, the class will be over. Now, the fourth problem, if x square plus y square equal to 6xy, prove that 2 log x plus y equal to log x plus log y plus 3 log 2. This is what we have to prove. So first we note down the given condition. Given x square plus y square equal to 6xy. We want to get the form x plus y whole square form on the left hand side. To get this form, we add 2xy on both sides. Adding 2xy on both sides. Adding 2xy on both sides, we get x square plus y square plus 2xy equal to 6xy plus 2xy. Hence, using the formula, using x plus y, otherwise I will write it in terms of a and b. A plus b whole square equal to a square plus b square plus 2ab. We can write the left hand side term x plus as x plus y. Left hand side can be written as x plus y whole square, and 6xy plus 2xy, it can be written as 8xy. 8xy. Now, taking logarithms on both sides. Taking logarithms on both sides. Taking logarithms on both sides. Taking logarithms on both sides, we can write log of x plus y whole square equal to log of 8xy. Students must remember, whenever we consider logarithm in class 10, we take the base as 10. If it is mentioned other value, then only we consider other value for base. So in all the cases, we consider base equal to 10. So I write here log base 10. Now we use two formulae using number 1 log x to the power of n to the base a equal to n log x base a on the left hand side term, and log x y z to the base a equal to log x to the base a plus log y to the base a plus log z to the base a. Now let us consider the left hand side. The left hand side can be written in the form of n log x base a using log x to the power of n to the base a equal to n log x base a. So we can write 2 log of x plus y to the base 10. This is equal to log 8 base 10 plus log x base 10 plus log y to the base 10. Here we used the second formula, this formula on the right hand side part. The right hand side part is of the form log xyz. If it is in the form of log xyz, then we can write it as log x to the base a plus log y to the base a plus log z to the base a. So now log 8 can be written as 2 cube. 8 can be written as 2 cube. So in place of log 8, we can write log 2 cube to the base 10 plus the remaining terms are written as it is. There is no change in the remaining terms. So now we can apply the formula log x to the power of n to the base a equal to n log x base a on this. So using log x to the power of n to the base a equal to n log x to the base a. Using this formula on log 2 to the power of 3 base 10, we can write it as 3 log 2 base 10. Therefore, this is log x base a. Therefore, we can write the step 2 log of x plus y base 10 equal to, so now we are using the formula on this. Log x to the power of n to the base a can be written as n log x to the base a. So using this formula on the above term, we can write it as 3 log 2 base 10 plus log x base a plus log y base a. So hence the result is proved. This is what we have to prove. So we can write hence the result is proved. Hence, the result is proved. Now, let us discuss this problem. If x square plus y square, if x square plus y square equal to 6xy, if this condition is satisfied, we have to prove the result. This is a result what we have to prove. To prove this result, we consider the given condition. The given condition is x square plus y square equal to 6xy. This is the given condition. Now, we want to get x plus y whole square on the left hand side of this term. This is the given condition. On the left hand side, we have x square plus y square. We want to get x plus y whole square on the left hand side. To get x plus y whole square on the left hand side, we should add 2xy on both sides. So this is the reason we added 2xy on both sides. So students must observe this, and you must understand the concept that we have added 2xy on both sides to get x plus y whole square form on the left hand side. This is the reason. Now, after getting x plus y whole square form on the left hand side equal to 8xy, we take logarithm on both sides. Taking logarithms on both sides, we can write this step. Now, the left hand side part is of the form log x to the power of n to the base a. So, compare these two. Then it can be written as n log x base a. After this step, we consider the right hand side term. The right hand side term is in the form of log xyz to the base a. And this can be expanded as log x to the base a plus log y to the base a plus log z to the base a. Now, we use first for this formula on the left hand side. So we can write the left hand side as 2 log of x plus y to the base 10. In the next step, log 8xy to the base 10. We use the second formula log xyz to the base a equal to log x base a plus log y base a plus log z base a. Using this formula, we can write this step. Now, after writing this step, we can write 2 cube in place of 8. In place of 8, we can write 2 cube. Now, this first term is of the form log x to the power of n to the base a. Log x to the power of n to the base a. So, we can write it as 3 log 2 base 10. 3 log 2 base 10. Here, I should write it base 10. This is base 10. This is base 10. Hence, the result is proved. Dear students, we have discussed the problem using method 1. Now, let us solve the same problem using method 2. I explained method 1 and method 2 in the earlier class also for a different problem. So now consider method 2. In method 2, we consider the right hand side part of the proof. So first we write given x square plus y square equal to 6xy. So this is the given condition. Now consider the right hand side part of the proof. Consider otherwise we can consider the left hand side part also. Consider 2 log of x plus y. This can be written as log of x plus y whole square. Here the base is 10. The base is 10. This is now using the formula log of x to the power of n to the base a equal to n log x. I will write it here. For using the formula log of x to the power of n to the base a equal to n log x to the base a 2 log of x plus y can be written as log of x plus y whole square to the base 10 here on both sides. So here this is the left hand side part of the proof. The left hand side part of the proof is considered. Now using this formula we can write it as log x plus y whole square to the base 10. Now we expand x plus y whole square. This can be written as log of x square plus y square plus 2xy to the base 10 to the base 10. Log of x square plus y square plus 2xy. This is using the formula a plus b whole square equal to a plus b whole square equal to a square plus b square plus 2ab. Using this formula, we can write this step. Now, it is given that x square plus y square equal to 6xy. So, in place of x square plus y square, I can write 6xy. So, this is equal to log of 6xy 6xy plus 2xy to the base 10. So we must write the reason here. Since x square plus y square equal to 6xy, we are just writing the reason. So this becomes log of 8xy. Now 2 log of x plus y to the base 10 equal to log of 8xy to the base 10. Using the formula log xyz equal to using log xyz to the base a equal to log x to the base a plus log y to the base a plus log z to the base a. We can write the right hand side as the right hand side can be written as log 8 to the base 10 plus log y to the base 10 plus log not y here x, and this is y to the base 10. The left hand side term is written as it is 2 log of x plus y to the base 10. Now log 8 we have 8 can be written as 2 to the power of 3. 8 can be written as 2 to the power of 3. So this can be written as this is equal to log 2 cube to the base 10 plus log x to the base 10 plus log y to the base 10. So this is equal to using the formula using log of x to the power of n to the base a equal to n log x to the base a. So this term can be expanded as 3 log 2 base 10. We can write it, so this is equal to, this can be written as 3 log 2 base 10. 3 log 2 base 10 plus log x base 10 plus log y base 10. This is the right hand side. Now we write the left hand side. 2 log of x plus y to the base 10. Hence the result is proved. Hence the result is proved. So remember here in this problem I have taken the left hand side part of the given condition. In the earlier problems I have considered the right hand side part of the given condition, and this is method 2. So in the earlier problems x square plus y square equal to 27xy, I have considered 27xy and I proved the result. So the same problem can be proved by method 3, but I would like to consider only 2 methods. In the earlier classes also I told you I would like to consider only 2 methods. Even though there are several methods to solve a problem, I would like to consider only 2 methods. Students can use any one of the methods, and if they want to solve the problems in different methods, you can solve the same problems in different methods. Let us discuss this problem. The given condition is noted down. Now we consider the left hand side part of the proof. 2 log of x plus y base 10. Now you use this formula log x to the power of n to the base a equal to n log x base a. Using this formula, we can write the left hand side part as log x plus y whole square to the base 10. Now we expand x plus y whole square using the formula a plus b whole square equal to a square plus b square plus 2ab. Using this formula, we can write x square plus y square plus y in place of x plus y whole square. But it is given that x plus x square plus y square is equal to 6xy. So in place of x square plus y square, I can write 6xy. So we will get log of 8xy on the right hand side. The right hand side becomes log of 8xy. Now, this is compared with the formula log xyz to the base a. Then we can write, we can expand it to log x to the base a plus log y to the base a plus log z to the base a. So now the right hand side part can be written as like this using the above formula. Here we have 8 in the logarithm. 8 can be written as 2 cube. 8 can be written as 2 cube. So this is of the form log x to the power of n to the base a, which can be written as n log x to the base a. So we have written that term as 3 log 2 base 10. Hence, the result is proved. This is method 2. If you want to consider the right hand side part, you can consider and prove the result. I would like to solve the last problem in this class for real numbers chapters. After the completion of the last problem, this chapter is the chapter will be completed. Fifth problem. Find the number of digits find the number of digits in 4 to the power of 4 to the power of 2013. 4 to the power of 2013 if log 2 base 10 equal to 0.3010. This is very interesting question. If any student can answer to this question, you respond in the chat box. If any student can answer to this question, you can respond. Here we consider or assume that, let us assume that let x equal to 4 to the power of 2013. 4 to the power of 2013. Now 4 can be written as 2 square. So 4 to the power of 2013 can be written as 2 square whole to the power of 2013. So this can be written as 2 power 2 multiplied by 2013. 2 multiplied by 2013. That equal to, we can write 2 to the power of 4026. So we can write it as this is equal to, we can write 2 to the power of 2 whole to the power of 2013. So this is equal to 2 to the power of 2 multiplied by 2013 equal to 2 to the power of 4026. So we have x equal to 2 to the power of 4026. Taking logarithm on both sides. Taking logarithm on both sides. Taking logarithm, so log x base 10 is equal to log 2 to the power of 4026 to the base 10. Using the formula, using log x to the power of n to the base a equal to n log x to the base a. N log x to the base a, we can write it as the right hand side becomes 4026 log 2 base 10. Here log x base 10. This is equal to 4026 multiplied by, what is log 2? It is given 0.3010. 0.3010. This is equal to we get 1217.8. So this is approximately equal to 1218. So how many digits are there now? Here let us see the problem. 4 to the power of 2013. Find the number of digits in it. If log 2 base 10 equal to 0.3010. Now let x equal to 4 to the power of 2013, taking logarithms on both sides. Now it can be written as x to the power of 4026. Taking logarithms on both sides, we can write log x to the base 10 equal to log of 2 to the power of 4026 to the base 10. So using logarithm formula, log x to the power of n to the base a equal to n log x to the base a. We write n multiplied by 4026 multiplied by log 2 base 10. But it is given that but it is given that log x to the base 10, it is given that log 2 base 10 equal to 0.3010. So after simplification, we get this is equal to 1218. So finally, we got log x to the base 10 equal to 1218. Now, by definition of logarithm, a to the power of x equal to n implies and implied by x equal to log n base a. So using this formula, here we have log x to the base 10. So we can write it as x equal to 10 to the power of 1218. Now, I would like to ask you one question. 10 to the power of 1, how equal to 10? 10 square equal to 100. 10 cube, this is equal to 1000. 10 power 4 equal to 10,000. So, I would like to ask you, so how many digits are there? 10 to the power of 1, 2 digits. In 10 square, 3 digits are there, 3 digits. In 10 to the power of 1, 2 digits. In 10 to the power of 3, how many digits are there? 4 digits. In 10 to the power of 4, 5 digits. Like that, if 10 to the power of n is given, then it has n plus 1 digits. So, using this formula, we can write 10 to the power of n has n plus 1 digits. Therefore, 10 to the power of 1218, 1218 x equal to 12 to the power of 10 to the power of 1218 has 1219 digits. Dear students, you just try to understand this concept. How we have proved this result. You have understood up to the step log x base 10 equal to 1218. So by the definition of logarithm a to the power of x equal to n implies and implied by x equal to log n base a, then we can write x equal to 10 to the power of 18. That is, what is x? 4000, 4 to the power of 2013. So we will write it. X equal to 4 to the power of 2013 and this is equal to 10 to the power of 1218. So that means the base 4 is converted to base 10 here, because we can find the answer with the base 10 very easily. So we used this property, 10 to the power of n has n plus 1 digits. We can write it very clearly, and we know that we can understand it with the help of examples. This is uh, this is how we proved the result. Hence, the result is proved. Hence, the result is proved. Dear students, we discussed all the problems in the chapter of real numbers of class 10, and I explained different methods to solve a problem. A single problem is explained using different methods. So you try to solve all these problems, and try to understand the basic concepts in mathematics. After getting command over mathematics, that is basic concepts of mathematics, you will be able to understand the concepts given in the chapters of the 10th class syllabus. Thank you all students. Thank you very much.